Hello everyone. Today we'll be automating an infrastructure related to the Ghost CMS which is hosted on the EC2. So typically the architecture is like this. We have an EC2 where we host the Ghost CMS which only provides the API as of now, since we will be building the site on the Netlify. So the EC2 instance will only be acting as the API server and will not host the website itself. So we don't need it all the time running, because most of the site would be running on the Netlify CDN. It would unnecessarily cost us more money if we keep on running the EC2 24/7. Also, we need to find a way to cut down the cost when starting or stopping the instance. So we will go with this architecture. So first of all, when we shut down the instance, we will create a lambda that will take the snapshot of the EBS volume that is attached to the EC2 instance and store it for the later purposes. Once we have the need to start the EC2 instance to update the site or make modifications, we will invoke another lambda that will take the snapshot that we created earlier, create a EBS volume and attach it to the EC2 instance that we have stopped. Once the EBS volume is attached to the EC2 instance and then we start it, once the EC2 instance is start, the IP will change, of course. So we need to update that IP with the domain that we usually use to access the Ghost instance. So we use another lambda to get the public IP of the EC2 instance, update it on the DNS provider that we have. I have in this case the Netlify DNS, which is easy to use with APIs as it provides a ready-made API for updating the DNS records. So this is the overall architecture. Since we have simplified and automated most of the processes, we just need to invoke one lambda to start the EC2 instance and another lambda to shut down the instance, which will save us money because the volume is preserved and also it is preserved as snapshot rather than a EBS volume, which will generally cost more compared to the snapshot, which is usually kept in the S3 buckets. And also the subdomain with the A record is taken care by the another lambda, so that we don't have to manually update the A records later on. Now let's dive into each of the lambda in more details. So this is the first lambda function that we'll be talking about. It will be involved in the events of shutting down the EC2 instance. This lambda function will be invoked by an EventBridge rule, which is after the shutting down of the EC2 instance. After it is invoked, it will use the snap-and-delete-volume role that we will be creating with certain permissions that I'll show you later in the implementation part. It will get the EBS volume of the EC2 instance that is attached and create a snapshot out of it, preserving all the data that we need so that we can create an EC2 instance later when we need the Ghost instance. So this is the structure of snap and delete volume lambda function and the components around it. Now let's dive into the other lambda functions. This is the next lambda function that we'll be talking about, that is create volume start instance lambda. This will be involved in starting the EC2 instance. So to start the instance, we need an EBS volume with all the data preserved in it. So we'll create a new EBS volume out of the latest snapshot that we took using the earlier lambda function. So after creating an EBS volume, we will attach it to the EC2 instance that we already have and start it. This task will be carried out using the particular role that we will create later on, that is create volume start instance role. After the EC2 instance is started, an EventBridge role will invoke another lambda function, that is create a record, that is present here. It will take care of updating the public IP with the A record of our particular domain from which we access the Ghost instance, the Netlify DNS that is present up here. So we update the A record in the Netlify DNS using the Netlify API and the access token. I'll provide you with the documentation on how to create the access token for Netlify in the description below. This task will also be carried out using a particular role that will create later on, that is create a record role. Enough for the theory. Now let's dive into the implementation part. Now let's start with the implementation part. I have logged into my AWS console. I assume you have created your AWS account and logged in. Make sure you have administrator permissions for the simplicity of this task. First we'll create an EC2 instance which will act as our Ghost instance. Let me create a demo EC2 instance 1. Click on instances. Click on launch instances. I'll give the name as Ghost EC2. Next we'll choose the AMI for the EC2 instance. For this demo I'll go with the Ubuntu. We'll remain within the free tier for the instance type. Let me choose a key pair that I already configured. We'll select the existing security group that I already created with necessary rules. We'll keep the storage as it is since it is a demo EC2 instance. Click on launch instance. To make sure we have some sort of data inside the EC2 instance, we'll create a demo website using the Apache server. Now let's connect into our server. We'll connect using the EC2 instance connect. Click on connect. We have got the shell. First we'll update the repositories using the following command: sudo apt update. Let me connect to it using my own terminal. Now that we are connected to the EC2 instance, let's install the Apache server using the following command. Navigate to the directory of var www.html. Open the index.html file. Insert a sample text that we want. In your case, it will be the Ghost instance, so you don't need to add any sample text. I am creating this only for the demo purposes, and in the real case, it will be the Ghost instance that we'll be interacting with. I'll exit the file, restart the HTTP server, restart the Apache server. Let's check the website how it looks. So this is the data that we have created. Generally, it would be the Ghost instance. Now let's look on to the lambda functions, where we will delete the volume of the EC2 instance and create the snapshot, and then recreate the volume when we need it. Let me close this tab. We also don't need this tab. First we need to create 3 roles. So for that we'll navigate into the IAM service, search for the IAM and click here. We need to create a role that will be used by the lambda function for certain permissions, so that it can interact with the EC2 instance and create a snapshot of the volume and start the instance when needed. So we'll create the first role, that is snap and delete volume. Click on roles here. Click on create role. This role will be used by an AWS service. The trusted entity type, let it be that. Use case will be lambda, since this role will be used by lambda. Click on next. We'll add the permissions later on. Click on next. Give the role name as snap and delete volume. So this role will be used by the lambda function. Let me give role lambda function with the name snap and delete volume, which will create the snapshot of the volume and delete it. Click on create role. I will search for the role that we created, snap and delete. You can see the role here. Now let's add the permissions that we need. Click on add permissions. Create inline policy. We'll add the policies using the JSON editor. Let me clear all this statement. I have provided the blog version of this video on my personal blog that I will link in the description of this video. You can get all the policies and all the lambda code from there. So now I have copied the policy. I'll paste it here. Click on next. We'll give the policy name as same as the role, snap and delete volume, and add policy at the last. Click on create policy. Now that we have added the necessary permissions, you can see that we added the permissions. Now let's move on to creating the next role, that is create volume start instance role. Click on create role. We will be following the same procedure as previous one. Click on lambda, next. Add the permissions later. Click on next. Give the role name as create volume start instance role. Click on create role. Search for the role that we created. Click on add permissions. Create inline policy. Click on JSON. Clear all the JSON here. Copy the policy from the blog. Paste it here. Click on next. Give the policy name same as the role name, like create volume start instance policy. Now that we added permissions for this role also, let's move on to the last role. Click on create role. Use case lambda. Add the permissions later. Give the role name as create a record. Click on create role. Search for the role that we created. Click on create policy. Click on add permissions. Create inline policy. Click on JSON. Clear all the JSON. Copy the policy from the blog. Paste it here. Click next. Give the policy name same as the role name. Create a record policy. So we have created the roles that are required for the lambda function to access the services. Now let's move on to the creation of lambda functions. Let's now create the first lambda. Search for the lambda in the search console. Click here. Click on create a function. So we'll author it from the scratch. Pick the function name as snap-and-delete-volume. Use the runtime as Python 3.10. Let the architecture be x86 64. Permissions. We will change the default execution role to use an existing role that you have already created. That is snap-and-delete-volume role. So this name will be matching with this. Make sure that. Now let's click on create function. We have to add a trigger for this lambda function. That is when the EC2 instance shut down. For that, we'll click on configuration. Here we can see that the timeout is 3 seconds. We'll edit that and go up to 30 seconds. Click on save. Now let's add the code for the lambda function. You can get this code from the log that I mentioned earlier. Let me click on deploy changes here. Before that, we have to add the instance ID. You can find this instance ID where we create the EC2 instance. Click on your particular instance, copy the instance ID from here and paste it here. Make sure that the region that is mentioned here is same as your EC2 instance is created. I can see that the EC2 instance is created in Mumbai, that is mentioned as EP-South-1. I can see that the region is specified correctly here. Make sure you mention that. Rest all we can leave as it is. Click on deploy. So the code is updated. Now let's add a trigger. For that we'll go to the EventBridge console. Click on create role. We close the other tab. Full name. This EventBridge will be triggered when the EC2 instance is off. Description is optional, so we'll leave it like that. Role with an event pattern. Click on next. So event source will be AWS events. Since we'll be getting the event from the AWS EC2, sample event is not required. We'll use the creation method AWS services. So we'll use the EC2. Event type will be EC2 instance state change notification. You click on specific state, that is stopped. Specify the specific instance ID that we have noted earlier. We paste that. You can also see the event pattern that we can manually write. Let's click on next. We'll use the target. This what will be triggered once the rule is satisfied. We'll choose the lambda that we have created earlier, lambda function, and we can specify the function that we have created, that is snap-and-delete-volume. Click on next. Don't need any text. Click on next. Make sure that all the details are correct. Let's click on create role. We have created the role successfully. Now let's stop the instance and check if the lambda function is invoked correctly or not. Let's go to the EC2 console. Before that, we'll check if the EventBridge rule is attached with the lambda function. Let's go into the lambda service. Click on the first function that we created. You should see the EventBridge rule appear here connected to this lambda function. As you can see, there is EventBridge rule. So we can proceed with the lambda function. So let's stop the EC2 instance and check if the snapshot is created in the instance state. From running to stop, on stop. You can see the instance is stopping. So let's check the CloudWatch log to see if the lambda function is running correctly or not. You should see a log tree created already. Go into log groups. As you can see, there is a log group already created. There should also be a log stream created. So we can see here a log stream is created. Let's click on it and we can see there are no devices that are attached to this system. That means we have successfully detected the volume. And also let's check the snapshot. As you can see, a snapshot is successfully created. Now we have made sure that the lambda and the EventBridge rule is working perfectly. Now let's move on to the next function, that is create volume start instance. Let's now move on to create the next function, that is create volume start instance. We'll do the same step as the previous one. Go to the lambda, create function, give the function name as create volume start instance. We'll give the runtime as Python 3.10. Change the default execution role. We'll use an existing role, that is create volume start instance. Here it is. Click on create function. This function we need to trigger it manually because we will start the EC2 instance only when we need it, not because of an automated way. So the only thing we have to change in this lambda function is the timeout and the code of the lambda function. Let's now first change the timeout. Edit here, change the timeout to 30 seconds, click save, go to the code, get the code. You can get this code in the blog section. After we paste the code, we have to make the necessary changes, that is the region name. Make sure that we have choose the correct region name where the EC2 instance is deployed. Next is the instance ID. We have to get it from the EC2 instance. Let me get it now. Paste the instance ID here. Also make sure the device name is correct for your AMI. For Ubuntu it is dev SDA1. If you have choose another AMI, make sure that you match the device name. You can find this in the volume section of the EC2 instance, that is storage. Here you can find the root device name, so make sure you change that appropriately. Rest we can leave as it is. Let's deploy the code. Now that we created the lambda function, let's test if the lambda is working correctly or not. For that we have to invoke the lambda manually. Let's do that. Click on test. Before that we have to check the EC2 instance status. You can see that the instance status is stopped and there is no volume attached here. Also, after we attach the volume, we have to make sure that the data is retained, like we install the Apache server and made a sample HTML page. Now let's test the lambda. Create a sample event. Click on test. Also, we can check the status in the CloudWatch logs. We will get another log group for this particular lambda function and another log stream. Also, you can check if the EC2 status is changed. You can see that the instance is running and also a volume is attached. Let's check if the data is retained. As we can see, the data is exactly retained as we took the snapshot. Let's check the log groups. You can see there is a log group create volume start instance. We'll find a log stream inside that. As you can see, there it is, the volume ID. We are creating the volume. This volume is available and then we attach the volume. So this lambda function is also working properly, as you can see here. Now let's move on to the final lambda, which will get the IP of this EC2 instance that is present here and will update the A record for the required domain that we hosted in the Netlify DNS. Before we create the last lambda function, we need a few prerequisites. That is the personal access token in the Netlify and a lambda layer, which I'll explain you very shortly. Make sure you have the domain registered in the Netlify DNS. As you can see, I have the sample domain registered here. This is my other domain used for testing purposes. As you can see, we have no DNS record here. After we use the lambda function, there should be a DNS record like ghost.epicbugs.tech, and then it will have the IP address of the instance that we start. Now let's get the personal access token. Click on your profile and then click on user settings. Go to OAuth. Click on new access token. Give a description for your token. Test lambda. Give the expiration date. Generate token. Copy this token and keep it safe somewhere. Click on done. Now that we have the personal access token, let's move on to create the lambda layer. Lambda layer is just a zip file which contains all the required modules to run the Python file. In this case, we are going to create a new lambda that will make API request to the Netlify DNS. In order to make API request, we need the request module in the Python, which is by default not available in the lambda runtime. We'll have to import it separately. So we'll create the zip file locally and then import it into the lambda. To create the zip file, enter your terminal, make a test folder, create a Python folder here. Enter into the Python folder. Now install all the dependencies that you need. In this case, we will require only the request module. We'll install that using this command. Since we need all the modules in the current directory and not globally, we use the following tag. Press enter. So we can see that all the necessary modules are installed. Now we need to zip the content of this folder along with the Python folder. So we'll move back one directory. You can see the Python folder here. So create a zip file using this command. Give a name that you prefer and the current directory with the Python folder. Press enter. So you can see that the zip file is created. You can see what is inside the zip file using the following command. As you can see, there is the Python folder and then all the required files inside it. As we have created the zip file, let's move on to creating the lambda function. Click on create function. Give the name as create a record. Select the runtime as Python 3.10. Change the default execution role. We have already created a role for that. Create a record. Click on create function. For this we need to create a trigger and also change the timeout. First change the timeout, edit, increase it to 30 seconds. Click on save. Next we need to add the layer. Before that, upload the layer to the lambda by going into layers, create layer. I'll give a name for that. First upload a zip file. So click on upload. So it is compatible in x86. Then runtime will be Python 3.10. Click create. So as you created the request layer, let's go on to the function and include that layer there. Create a record, click on layer, add a layer, choose custom layer, click and then select the one that we uploaded. Custom, keep it as 1 for now. Click on add. Next we need to add the trigger. For that we'll go into the EventBridge. Click on create role. The role name is EC2 go start. Since we'll be invoking this role when the EC2 instance starts, let's all keep it as default. Click on next. We don't need sample event. We use the pattern from AWS services. We need the options like the previous one, like EC2 here. Then type instance state change notification, specific state. Instead of giving the stop, we'll get on running in the specific instance ID. We'll get the instance ID here, click on next. So we'll choose the target, that is click on lambda, choose the function name, that is create a record, click on next. We don't need tags, check if everything is okay, and then click on create rule. Next we'll go on to lambda, go to the function. We'll be seeing the EventBridge rule appear here. As you can see, the EventBridge rule has appeared. Next we'll get the code for the lambda function. Get the code from the blog, paste it here. We'll have to make some changes before we deploy this code. As usual, we'll have to change the instance ID. Record type will be A, as that is the required one. We'll change the domain here. Make sure you get this right. We'll have to add the environment variable that we with the access token that we created here. Make sure the region is correct. Domain. This is where you specify the root domain. In our case, it will be epicbox.tech. This is required to get the DNS records that are associated with this domain. Rest all looks clear. Let's deploy the changes. Also, we have to add the access token. Let's add that on environment variable. Let me grab the environment variable name. Go to configuration. Edit the environment variable. Add and then paste the access token that you have created. Click on save. Now we have the lambda function ready. We have the access token. We have added the layer. We have added the trigger. So I will do one thing. We will trigger this using the EventBridge rule. For that we have to stop the instance and start it again. If we stop it, it will invoke another lambda, that is the snap-and-delete-volume. So let's do that and come again to this lambda. As we stop it. So this will create another snapshot. Let's wait and see if the another snapshot is created. As you can see, another snapshot is created. So now start the EC2 instance using the lambda that we have created. Create volume start instance. This will create the volume of the latest snapshot that we have created. If there are more than one snapshot available, as this lambda is manually invoked, you can invoke this using this step. Let's create a snapple event. Test all looks good. Let's test the event. Once this starts the EC2 instance, this lambda should be invoked because of the EventBridge rule, and we should get the domain here. Let's check that. epicbox.tech. You should see a domain up here. You can see the one lambda function is successful. And let's check if the create a record function is successful or not. As you can see, the domain is added with the IP address of 5266.35.246. Let's check the IP same or not. As you can see, the IP is correct. Let's go to the instance. Click on the IP address. As you can see, the IP is loading. Let's check the domain also. Due to a small error in my DNS provider, I could not show the DNS propagation. It would work fine if you have come up to this stage. So as you can see, the 3 lambda functions have been executed perfectly. So this is how you automate the Ghost EC2 instance to reduce the cost that is associated with the running of the EC2 instance. We have automated the way of removing the volume from the EC2 instance and keep it as a snapshot so that we can reduce the cost. And also we have automated the way to start the EC2 instance when we need it, so that we don't have to manually do all the tasks. You can simply invoke a lambda function. It will take care of all the tasks that are needed to start the EC2 instance, that is creating the volume, attaching it to the EC2, get the public IP and update it in the Netlify DNS. That's it for this one. If you have found this video helpful, like and subscribe to the channel for more such videos. Thank you.